Hey guys, today we're going to talk about 7.1, calculating standard deviation. Being able to calculate by hand and using those algebraic skills will help you a lot with normal distributions as well as with confidence intervals that we'll get to in the next unit. So a standard deviation measures how each value in a data set varies or deviates from the mean. It shows variation in data, so how much a data set or how much a data point varies from the rest of the data set. So if you have everyone in a class that gets 100 and then you have a student who gets a 0, how does that 0 affect how far each of those values are from the mean? If data is really close together, the standard deviation is small. If data is really spread out, the standard deviation will be large. It's often denoted by a lowercase Greek letter sigma, but let's just talk about what you're going to see in your calculator when we eventually get to that. So in the calculator, there are two different types of standard deviation that we can calculate. There's a standard deviation for the population, and it has a sigma. So typically we use that sigma for my standard deviation. But you also have SX, and both of those values are calculations of a standard deviation. This guy in the calculator is the population standard deviation. So there's no adjustment of error for what we think the data could be varying by. This is a sample standard deviation. We always look at a sample standard deviation to predict the population standard deviation. You can never accurately calculate a population standard deviation because you're only using a small set of data in order to calculate that value. Now, there's different ways to differentiate between the two of them, but know that we're going to be looking mostly at sample standard deviations because that's going to show us the variation between that data set in prediction of the population. So here's kind of just an example of what I was talking about between what happens when a standard deviation is smaller or larger, etc. So here you're talking about IQs for verbal, math, and spatial. So we have a standard deviation of 7.9, a standard deviation of 15.8, and a standard deviation of 31.6. So ask yourself which one of those standard deviations is the smallest. And you should be looking at the verbal one. That 7.9 is the smallest versus the 31.6 is the largest. Now, what's the difference between these two graphs? One of the graphs is really skinny and tall, and the other one is short and more spread out. So this shows me that the variation between my data only goes between roughly 78, mostly between 78 and let's 130. Whereas a larger standard deviation is going to have a much larger spread. It's going to have a larger standard deviation and a larger variation of data. So the larger the standard deviation, the more spread out your data is. The smaller the standard deviation, the less spread it is. So here's how you're going to actually calculate the steps to finding the standard deviation. So the first step is you take the mean of all the data. So that's going to be using the X with the bar on top. Then you find the difference between each value and the mean. So you take each data point and you subtract the mean. That could give you negative or positive values, but that doesn't matter because the next step says to square those differences. And we know that when we square differences, they're always going to be positive because we're trying to see distance away from the mean, so distance is always positive. This little guy right here says find the sum of all of those differences squared and then divide by how many total there are. You take the square root to find the standard deviation. So a lot of different websites, if you look up how to find the standard deviation, they sometimes divide by n minus 1. And the reason that we sometimes divide by n minus 1 is to account for any error that can happen when you have a sample. So when you have a small sample, there's always going to be variability. It's not always perfectly representative of the entire population. So by dividing by n minus 1, we kind of adjust for the fact that there's this variation and deviation between the data sets, and that adjusts for it. But for this one, we're just going to find by hand by dividing by n. So let's try it. So find the mean and the standard deviation of the values. And I really want you to try to do this without a calculator at all. So that's going to be kind of fun. So only 4 values. So find the average. You add up all of them and divide by how many there are. So we have 10 plus 14, so 24, divided by 4. So my mean is 6. So this little box says to put every value, so the 9, the 4, the 5, the 6, and this really helps you when you're organizing your data if you set up this little table. The mean of each of those is 6. And for the next part, we're going to subtract each of the values minus the mean. Again, notice that I'm getting some negative values, and that's totally cool. Then I'm going to square each of those differences. So 3 squared is 9, negative 2 squared is 4. You need to remember that when you square a negative, it's still positive. Okay, from here, we're going to add those all up. So we want the sum of those values squared. So 9 plus 4 plus 1 is 14. And you're going to divide by how many there are total, which is 4. 14 divided by 4 is roughly 3.5, and I did cheat on that one, so maybe when you get to the harder ones. But I think you guys could do it. And then take the square root of that. Now that's where you're definitely probably going to need a calculator. So take the square root of 3.5, that's going to give me 1.87. So my standard deviation is 1.87, and I'm going to write it with SX, even though it's not perfectly statistical, because that's what your calculator might show you. So my standard deviation, 1.87. I always round to 2 decimal places. All right, let's look at another one. So we have the standard deviation for the following dog heights. So we've got a bunch of dogs, different heights. You measure to the back. The first step we found was finding the average. Well, I'm going to go ahead and I'm just going to write in this box all of those values. I'm going to find the average of those values. So 600 plus 470 plus 170 plus 430 plus 300. Divide that by 5. That gives me 394. 394, 394. Subtract all those values. So you definitely probably are going to need a calculator, because I know you guys tend to struggle with some of that math in the brain. So 394. And I myself am using a calculator too. So 394, negative 224. Especially when we start squaring these guys, because that's going to be kind of tough. 430 minus 394. 36, 300 minus 394. Negative 94. All right, we're going to square all those values. 206 squared is 42,436. 76 squared, 5776. 224 or negative 224 squared, both are equal to the same thing, so 50176. 36 squared, 1296. 94 squared is 8836. I'm going to add those all together. That's going to give me 42436 plus 5776, 50176, 1296 plus 8836. That gives me 108,520. You're going to divide that by how many total there were. There is 5. So that is 21704. Last step, always take the square root. And my standard deviation is 147.32. So there's a lot of variation in this data. There's not, each of those values, there's a lot of, you can almost kind of visualize the differences between them. There's a lot of main differences between them, making that standard deviation larger. All right, using the standard deviation. So this is an important slide here. It's going to tell us how to interpret the standard deviation. So on a quiz, it might ask you to interpret. You really want to use this language in your interpretation. So using the standard deviation, we can typically say that, talk about the context, is blank standard deviations away from the true population. So maybe you'll say, using standard deviation, we can typically say that dog heights, that's kind of the example that we just used, are typically, let me go back to what it is, 147.32 centimeters away from the true population mean. Again, we're using this sample standard deviation to talk about the population. So here's some examples for you. People born on an even day. So there's 2 different test scores. What you're going to do is just practice on this. So try to calculate the standard deviation for both of these values. try to interpret the standard deviation, and then we'll compare them. And you can also actually do this with a calculator. So the calculator is the exact same way that you've been doing. You can go to stat, or if you're using the TI-30, which I'm starting to recommend that you don't, we're using those TI-84s now because normal distributions, inverse norms, are all going to use the different functions on a calculator. So you're going to go to stat, press edit, and I'm just reading through these little pictures. You go to L1, put all your values into L1, so that's all your X values. 1 var stats, that's going to give you what we've used to find the mean, the minimum, Q1, the median, Q3, the max, etc. And then what you are looking for is SX. Again, that's the sample standard deviation. So try the 2 examples up here by hand, and then try to complete this ticket out the door. Send it to your teacher so you can get some feedback to see if you're using the right wording for your interpreting, to see if you're calculating your standard